Assalamu alaikum warahmatullahi wabarakatuh.
Welcome to the deep dive.
Great to be here.
Today, we're plunging into, well, a really fascinating intersection of automotive history and modern engineering. We're talking about recreating iconic cars, but, at a smaller scale.
And specifically, that really compelling desire people have to bring back the mechanical feel of a manual transmission into these modern, often electric replicas.
It's such a cool blend, isn't it? Heritage, engineering, pure passion.
Absolutely. And we've got a great stack of material from you, the listener, covering, well, everything.
Yeah, from the drivetrain of a legendary classic
to the incredible detail in building these scaled replicas.
and even getting into the nitty-gritty of swapping in different powertrains. Engine swaps, gearbox swaps.
So our mission today,
Let's try and extract the essential insights from all this, understand the technical hurdles.
and really dig into what drives this passion, this blend of old and new.
Okay then, let's unpack this.
Where should we start? Maybe with the original inspiration?
Good idea. Let's look at the 1924 Bugatti Type 35. The material you sent over really details its drivetrain. Groundbreaking stuff.
It really was. A 2.0-liter inline 8-cylinder engine. Single overhead cam.
Yep, SOHC. Putting out around 90 horsepower, which back then
Was significant. And the sources highlight the focus on lightweight design. An aluminum block built to rev high for racing.
Exactly. And crucially for our chat today,
The gearbox.
the gearbox, a 4-speed manual transmission, conventional H-pattern shift.
And built tough, right? To handle the engine's power and give that driver precise direct control.
That's what defined early Grand Prix racing, wasn't it? That level of control.
Absolutely. That whole package, lightweight, powerful for its time, mechanically precise. It's why the Type 35 is legendary.
That direct connection, driver, engine, wheels, just pure mechanic.
It was the peak of mechanical engagement for that era, no question.
So you got this icon defined by that raw mechanical feel. How on earth do you capture that in a modern replica, especially a smaller one?
Well, that brings us to companies like the Little Car Company. The material highlights their approach, and it's pretty sophisticated.
They focus on these precise 3/4 scale reproductions, right? Like the Bugatti Baby. That was what we mentioned.
Exactly, a 34 scale Type 35. But it's not just, shrinking a picture.
No, the sources say it's comprehensive reverse engineering.
Deep stuff. For the Baby 2, they actually scanned an entire original Type 35.
Every single component.
Every component, and then systematically reduced the scale by 25%.
That level of detail is just wow.
It has to be, because scaling isn't simple. You can't just shrink everything equally.
You've got to preserve critical ratios, the material says.
Right, like the wheelbase 2.76 meters becomes 2.07, track width 0.99 meters to 0.74.
And even the suspension geometry needs complex adjustments, using physics equations to get it right.
Things like scaling the roll center height by 34. It's properly engineered.
Okay, here's where it gets really fascinating for me. The material mentions the scaling paradox.
Ah, yes. The idea that 75% scale doesn't mean 75% of the parts.
Exactly. It sounds wrong, but a 75% scale car, like the Bugatti Baby, still needs almost the same number of components.
Around 700 parts, same as the full size roughly.
So the complexity doesn't really scale down?
Not in terms of component count. The cost savings are mostly in the volume of material used.
Ah, I see. But systems like steering, electronics, safety gear,
They remain complex, pretty much regardless of the final size. You're still dealing with full-size system complexity just squeezed down. That drives a lot of the engineering effort and cost.
and these replicas, they're a mix, aren't they? Old and new.
Definitely. They keep historical bits, like maybe traditional suspension elements.
But add modern tech for safety and usability. Lithium-ion batteries, electric motors, LED headlights, that kind of thing.
Production is low volume. They outsource a lot, maybe 90% of components to specialists.
But keep critical custom stuff in-house, like basic machining.
Exactly. And quality control is rigorous. Test driving, even track testing.
And let's be clear, these aren't toys. The material positions them as luxury recreational products.
Yeah, prices reflect that. $37,000 up to nearly $80,000. Serious machines, even at 34 scale.
Okay, so the standard Bugatti Baby Second, the one they scanned the Type 35 for, it's electric, right?
That's right. As described in the sources, the standard one is an EV.
The typical powertrain is what, a 12 kilowatt brushless DC motor, about 13 horsepower?
Sounds about right. Powered by a 72-volt lithium iron phosphate battery pack, Life PO4.
which gives it decent performance for its size, top speeds near 30 mph.
Yep, and it includes modern EV features, multiple power modes, regen braking.
And that speed key thing, like the original Bugatti Veyron had, right?
Yeah.
Unlocks full power.
A nice little nod to the brand's history. Yeah, removes the speed limiter.
So visually, it's a stunning Type 35 replica, but the driving experience is modern electric. Smooth, quiet.
Which is great.
Yeah.
But for some enthusiasts, that core element of the original, that feel,
The mechanical engagement of shifting gears manually.
that's the missing piece. For many, the authentic classic car vibe is clutch pedal, H-pattern, engine noise.
Okay, so if you want to add that back in, it's a challenge. Let's quickly recap how a traditional manual gearbox even works based on the material. Its job is basically matching engine speed and torque to the wheels, right?
Fundamentally, yes. You've got shafts and gears. Input shaft from the engine via the clutch.
Counter shaft, output shaft to the wheels, and gears of different sizes for different ratios.
And the magic bits are the synchronizers.
Ah, the synchros. They use friction to match speeds before the gears lock together.
Exactly. So you get smooth shifts. The shift lever moves forks, the forks slide collars, and engage those synchros.
And pressing the clutch pedal
Disconnects the engine spin from the transmission. That's what allows the synchros to work without grinding gears.
Most modern manuals use constant mesh, right? Gears always spinning, but only the selected one is locked to the output shaft.
Correct. And reverse uses an extra idler gear to change direction.
Plus, the clutch is vital for stopping without stalling the engine. It's that crucial connect-disconnect.
So you can see why just dropping a manual box into an EV platform isn't straightforward. You need something to drive it and the whole control system.
Right, adding a proper manual, and usually that means adding a combustion engine too, to one of these scaled electric replicas. The material makes it sound like a major undertaking.
Oh, it absolutely is. Complex stuff.
The material even outlines building a DIY 6-speed manual gearbox from scratch.
Yeah, that's like the extreme end of ambitious, isn't it?
Totally. Design, CAD modeling, machining hardened steel gears, shafts, housing.
Then assembly, testing. Huge project.
And the sources specifically warn about potential blind spots in gearbox design, things you might overlook.
Like the sheer mechanical stress on shafts and gears.
Yeah.
Can't just glue stuff together.
Needs proper splines or press fits to handle the torque,
Yeah.
not just adhesive.
Absolutely. Material strength is critical too. Picking the right steel, hardening it properly.
And just designing the H-pattern shift mechanism itself sounds tricky. Getting the gates right, the detent springs that hold it in gear.
Reverse lockout so you don't accidentally hit reverse at speed. The material implies a lot of prototyping. Trial and error is often needed.
Avoiding gear clash, making it feel right.
And then there's the clutch interface.
Mm-hmm.
Problems often come from clutch drag or just not being adjusted right. That can wreck a gearbox or make shifting horrible.
So let's make it concrete. The material looks at a specific example, the Aston Martin DB5 Junior, and the idea of putting in a motorcycle engine and transmission.
Right. The discussion focuses on something like a Yamaha MT-07 engine. It's a 689cc parallel twin.
Compact, decent power, about 73 horsepower. Seems like a good fit size-wise.
But here's the rub. As material points out, that engine usually comes with a 6-speed sequential gearbox.
Ah, not an H-pattern. Push forward for upshifts, pull back for downshifts kind of thing.
Exactly. And converting that to an H-pattern, that's a massive technical hurdle.
Why is it so hard? The material touches on this.
Well, they work fundamentally differently. Sequential uses that linear lever movement and an internal ratchet mechanism to go through gears in order, 1 and 2, 3, 4.
Whereas each pattern is a 2D gate. You can jump gears fourth to second, say.
Right. The sources describe converting the internal mechanism as, well, theoretically possible maybe, but extremely complex, rare, needs massive internal redesign.
So not really practical. Better to find an H-pattern box.
Generally, yes.
Yeah.
Source one or build one designed for H-pattern shifting from the get-go.
Okay, so for this DB5 Junior conversion concept in the material, what was the workaround?
They talk about keeping the sequential gearbox, but modifying the external shift linkage, trying to make it feel like an H-pattern. Using a custom-made billet gate mechanism and Heim joint rods, those adjustable ball joint linkages.
So you move the lever in an H-pattern, but the linkage translates that into the forward-backward, nudges the sequential box needs.
That's the idea, trying to replicate the feel in the gate pattern, even though the box itself is still sequential internally. It's clever, but complex.
And this whole engine gearbox swap needs huge chassis changes too, right?
Oh yeah. Structural reinforcements, cutting the floor for a transmission tunnel, custom mounts for the engine and gearbox.
The material mentions drawing on lessons from classic mini subframe swaps. Fitting big things in small spaces.
Exactly that kind of thinking. Plus, you need a chain drive to the differential. Maybe adapt an LSD from something small like a Suzuki Cappuccino.
Add cooling radiators. Fabricate a custom exhaust.
Which brings its own heat management problems, especially near bodywork.
And you need a hydraulic clutch system, maybe using motorcycle parts like Magura. Custom gauges, too, swap the battery meter for a tachometer.
All adds up.
And the material flags the really critical challenges in this conversion.
Engine vibration is a big one in a small chassis.
That conflict between the sequential internals and the desired H-pattern linkage feel. Fighting the mechanism.
Potentially, yeah.
Yeah.
Getting that linkage just right would be tough. And managing heat from the exhaust.
And the cost, just for the parts for this specific conversion.
The estimate mentioned is somewhere between $8,000 and $12,000. And that's just components, not labor or fabrication time.
Wow. Okay, so it really drives home the point. Getting that manual shift feel with a combustion engine in one of these scaled replicas is serious engineering, not just dropping parts in.
Far from it. A major undertaking.
And beyond just the mechanics, the clicks and clacks. Part of the appeal is the sound and feel, isn't it? The whole sensory package.
Definitely. The material touches on the subjective idea of the best-sounding motorcycle engines.
Yeah, V-twins with their rumble or rasp, inline fours screaming at high revs.
Triples with their unique blend, boxers of that flat, throaty sound.
It really highlights that replicating the experience goes way beyond just the mechanical function. It's the sound, the vibration, the whole visceral thing.
You're not just operating it, you're interacting with it through multiple senses. That's key to the appeal for many.
Okay, let's circle back quickly to those potential blind spots the material highlighted. Things to watch out for when tackling projects like this, beyond just getting it running initially.
Right, important stuff like ongoing inspection and maintenance often gets overlooked.
Because it's hard to access things, or costly. Design needs to plan for it.
Maybe inspection ports, easy access panels, that kind of thing.
Then we mentioned material selection and assembly methods being critical under load.
Using proper mechanical fixings, not just glue, understanding the stresses involved.
The reliability of the shift mechanism itself. Those detents, gates, lockouts, they need to work reliably every time.
Meticulous design and testing there, absolutely.
And the clutch system again. Getting it right is vital to avoid gearbox issues down the line.
Proper setup, adjustment, making sure the driver interaction isn't causing undue wear.
Environmental factors, too. Temperature, humidity affecting components, especially any electronics involved.
Good point. And overarching all of that.
Safety, considering failure modes, billing and safeguards.
It's a good reminder that bringing these machines to life, especially modified ones, needs obsessive attention to detail. Anticipating problems, not just reacting.
Exactly. Every single stage matters. Wow. Okay, we have covered a lot of ground here. A real deep dive.
We certainly have. From the original Bugatti Type 35's mechanical heart
through the really sophisticated world of modern scaled replicas like the Electric Baby 2.
And then deep into that technical rabbit hole of adding a manual transmission.
Whether building one from scratch, which is incredible, or adapting complex systems in a major swap like the DB5 Junior concept.
It's just so clear, isn't it? Building these high-quality replicas and especially modifying them for that specific driving feel.
It's this amazing blend of history, craft, modern engineering, and just painstaking detail.
Preserving heritage, but also tackling huge challenges in scaling, materials, integration, supply chains.
All while thinking about the driver, the interface, and what could go wrong.
And that desire, that really intense desire for the authentic manual feel in these little cars.
It's not just about the mechanics, is it? It's the sound, the vibration, the feeling of control.
That engaged sense you get from actually shifting gears yourself.
So wrapping this up, what does it all mean? When you look at the sheer technical effort, the cost, the engineering puzzles involved in putting a combustion engine and a manual gearbox into one of these scaled replicas.
What's the real driving force? Is it primarily about perfectly replicating history's mechanics? Or is it maybe more about the challenge itself, the satisfaction of solving those incredibly complex engineering problems?
That's a great question. What aspect of that authentic experience do you think truly motivates someone to pour all that effort, time, and money into such a demanding project? Something for you to think about.